Students, today we are going to discuss the isomerism in the coordination compounds. We know that isomers are the compounds having the same molecular formula, but they have the different structures. When they have different structures, they have the different properties and they show different physical and chemical properties because they have different structures. And when we talk about coordination compounds, they show two types of isomerism just similar to other compounds. First one is the structural isomerism and another one is the stereoisomerism. So coordination compounds show two types of the isomerism as usual, and first one is the structural isomerism and second is the stereoisomerism. Now structural isomerism is of 6 types. Now we will discuss it in detail. First type of the structural isomerism which we are going to study is the ionization isomerism. Ionization isomerism. Ionization isomerism. As the name indicates that there will be difference in the ions that will be formed in the solution. So we can say that those coordination compounds which are the same molecular formula, but when they are in the solution form they give different ions. They will be covered under the ionization isomerism. For example, we are taking here example of the compound CONH3 whole 5Br and SO4 and CONH3 whole 5 SO4 Br. Here this compound is called pentaamine bromocobalt 3 sulfate. This is with a red violet color, while this compound is called the pentaamine sulfato cobalt 3 bromide. It is of the red color. These have the same molecular formula, but they have different atoms or ions that is in the coordination sphere and in the just outside the coordination sphere, which will be given as the ions. This when ionized, this compound when ionized, it will give CONH3 whole 5Br 2 plus and SO4 2 negative. Means this coordination sphere will be given as one ion and this SO4 2 negative will be given as the second ion, and this will give the test of the sulfate ion. But this compound, which will also be with the same molecular formula, this will be ionizing like this. CONH3 whole 5 SO4 positive, this plus Br negative. Now when we will test it, this will give the test of the bromide ion, but this will give the test of the sulfate ion. So these type of ions which have the different atoms or the groups inside and outside the coordination sphere, but they have the same molecular formula, they will be covered under the ionization isomerism. So this is the example of the isomerism, this ionization isomerism. Now the second type of structural isomerism is the hydrate isomerism, when we say hydrate isomerism, means we are talking about the number of the water molecules that is inside the sphere and is outside the sphere. So those compounds which have the same molecular formula but they have the different number of the water molecules inside and outside the sphere, that will they will be different in the number of the water molecules. For example, let's discuss CrCl3 6H2O. This will give three isomers. One will be CrH2O whole 6, means coordination sphere has 6 molecules of water, Cl3. So next possibility is that next isomer is that CrH2O whole 5 and one Cl inside and Cl2H2O, and another is CrH2O whole 4 Cl2 Cl and 2H2O. So you are looking here that for the first there is all the water molecules that are inside the coordination sphere, means it will not lose water, and in the case of the second, this has just one water molecule that is present outside the coordination sphere, so it can lose one molecule of water, and in case of the third one, that is it has two water molecules outside the coordination sphere, so it's going to lose two water molecules. So these type of compounds which have the same molecular formula but they differ in the number of the water molecules inside the and outside the coordination sphere are considered under the hydrate isomerism. And the next type of isomerism which we are going to discuss is a coordination isomerism. This is also a type of the structural isomerism, and in this C part is the coordination isomerism. Coordination isomerism. When we say coordination isomerism, that is we are talking about the distribution of the ligands which are coordinated to the central metal ion, and this type of isomerism is seen in the compounds which have both cationic and anionic forms, and they have the different distribution of the ligands that are around the metal ion. For example, let's see this CONH3 whole 6 CrCN whole 6 and CrNH3 whole 6 and CN whole 6. When you look at this compound, it has the same molecular formula, but here the cobalt metal ion is linked with the 6 ammonium while in case of this the cobalt is linked with the 6 cyanide ions, means we have difference in the distribution of the ligands. Here we are showing ammonia with cobalt and here ammonia with chromium, and cyanide with chromium and cyanide with cobalt. So this type of isomerism which have the different distribution of the ligands but they have the same molecular formula, they will be considered under the coordination isomerism.